All right, so again, this is day 22. It's on the back of day 21 notes. So we are going to start. Are y'all ready? I'm ready. All right, before we start, you need to write at the top of your paper, check for missing terms. If you don't do that, we're going to get the wrong answers. You got to check for missing terms. So write that down, check for missing terms. And filling out the blanks. Synthetic division can only be used when the divisor is linear. What it means is you have to be dividing by the biggest x. It has to be x to the first power. X to the first power. So I put a little 1 there. So if you'll notice, the first two examples that we see, we have x plus 3 and x minus 1. The highest exponent in either one of those is to the first power. So whenever you're dividing by the highest exponent is to the first power, which is what you see there and what you see there, whenever the highest exponent is to the first power, you can use synthetic division. Otherwise, you cannot. I'm about to teach it to you. So synthetic division, before we can begin, we have to check for missing terms. So looking at our first problem, we've got to the third and then to the first. Am I missing terms? Yes. So I need to add those in. I'm missing plus 0x squared. And I'm missing at the end just plus 0. I'm missing a constant. So I'm missing terms here. When I set this up, I have to first identify looking at the denominator. If this was a factor and I told you to find me solutions, if x plus 3 is a factor and I set it equal to 0, what does x equal? We've done this before. So if this is a factor, or if I was to set this equal to 0, what would x be? -3. Remember, it's opposite. So I have to first change it. So x is equal to -3. Once I've done that, and it's pretty easy. So like, let's practice here. If this is x minus 1, then what would x equal? +1. So off to the side, I'm going to say x is equal to 1. So you have to first change the sign of what you're dividing by. And then that number is going to go out and it's these set up kind of funny. So if you want to just watch me work through the first problem, I will give you time to copy it all down. So, and I highly encourage you to do that. This is kind of a fast process. So instead of trying to copy it down as I'm talking and working through it, just watch me with the first example. I promise I'll give you time that you can copy it all down. So you're going to take this number. In this case, it's a -3. In this case, it's a 1. And you write it in the front and you put it in a little house. Then I'm going to take only the coefficients of what I'm dividing into. So this. I'm going to take, and I'm going to write them in order with no x's anymore, only the coefficients. So what I'm going to write down is 3, 0, -27, and 0. I'm leaving off the x's. And so it's going to look like this. 3, 0, -27, 0. And I'm going to just put the numbers, no variables. Then I am going to set it up. I'm going to leave myself a space because I'm going to write stuff here. And before I ever get started, like what gets me started is I have to first drop it like it's hot. And I put a 3 down here. So I'll give you time that you can get caught up with me by just writing those things down. Any questions on how I got any of those numbers? Okay, write that down.
And you drop the 3 down.
That's how you start the problem every time. That's just how you start. Drop it like it's hot. So a lot of times students like set it up and they're like, I don't know how to start. First step, drop it like it's hot.
Just that first extra copy of the notes.
From last class. the notes in the homework from last class, and so the notes are going to be. All right, from here, this process goes really fast. So again, don't try and copy it down. I'll give you time once I'm done that you can fill in the blanks. But what we do, first step, that way that we start is drop it like it's hot. From here, I'm going to multiply, always multiply the number I get here by what I have in the little box. And then I'm going to add straight down. So I'm going to talk through it, what I'm saying. So if you watch me, you'll kind of be able to follow along a little better. So 3 times -3 is -9, and then I add it. So 0 minus 9, I get -9. Multiply. Negative times a negative is going to be a positive. 9 times 3 is 27. -27 plus 27 is 0. Anything times 0 is 0. 0 plus 0 is 0. That's it. That's how we do it. So I'll give you a minute so you can fill this out, and then I'll tell you what we do with it for our answer. How did we get positive 27? I did -9 times -3 gives me positive 27. So our first step, we drop it like it's hot. We multiply, add, multiply, add, multiply, add. So you can copy it down to here. Again, we drop it like it's hot, then we multiply, add, multiply, add, multiply, add. With long division, every step we subtracted, right? Or we changed the sign. We don't have to do that because in the very beginning, from +3 to -3, we changed the sign from the very beginning. That's why we don't have to change the signs every time. We're not subtracting anymore. From here, what I'm going to do is I'm going to label my bottom row. I'm going to label my bottom row, and it's going to start the same every time. And this may seem like a really silly step to you, but those of you that don't do it, you're going to get wrong answers. So please just trust me. We're going to start the very last number in the bottom row to the right. That will always be my remainder. And then I'm going to count up with a degree. So I will always have a remainder. The next placeholder will be a constant. And then I have an x to the first power and then an x to the second power. And if I had more numbers, I would keep climbing up, x to the third, x to the fourth, x to the fifth. But you always start out like that. You have to start on the right. The right is the remainder, constant, x to the first, x to the second. Any questions on how I label the placeholders of the very bottom line? And one way that you can check yourself, this problem started out to the third power. You're always going to be one less degree or one less exponent because we're taking one of them out. So I started it with x to the third. I'm ending with x to the second. So I know I did it correctly. My result, I'm going to take the bottom line and I'm going to rewrite it. So I have 3x squared minus 9x. Do I have to write to the first power? No. Do I have to write plus 0? No. And I don't have to write remainder 0 either. So this is my result. Like that is it. Would you say that x plus 3 is a factor? Why? Yeah, so yes, because the remainder is equal to 0. This is a much faster process than long division, but the only setback is that you can only use it when you're dividing by x plus or minus something. You can't have a bunch of terms or anything above x to the first power. Let's do it again. So I'm going to set it up. Do y'all see what kind of mess is going on up here? I got to check for missing terms. What's wrong with the top? It's not written in order, so it's all out of order. I'm never going to give you that on a quiz or a test, but if you did see something like this on a homework, we can fix it. Let's just write it in the correct order. And in doing so, we'll be able to see if we have any missing terms. So this is the same thing as negative x to the third plus 2x squared minus 3x plus 5 divided by x minus 1. So I have 3, 2, 1, and then none. So I don't have any missing placeholders. I'm good. It was just all scrambled. It wasn't in the right order. So I'm going to set up my problem. I'm going to put 1 in the box. And then I'm going to only write down the coefficients. When there isn't a number there, what is it?
1.
1. So I've got negative 1, 2, negative 3, 5. One thing that I like to do, because it's easy to accidentally skip a term, is just double check that I should have 1, 2, 3, 4 numbers. 1, 2, 3, 4 numbers. I'm going to set up my division problem, and my first step always is to drop it like it's hot. From there, I will multiply and add, multiply and add, multiply and add. So I get negative 1 times 1. So I get negative 1. 2 minus 1. 1. 1 times 1 is 1. Negative 3 plus 1. Negative 2. And then negative 2 times 1 is negative 2. 5 minus 2 is 3. I'm going to go ahead and label the placeholders on the bottom. I know that I started out with something to the third power, so I should end here to the second power. So I have my remainder, my constant, x to the first, x to the second. I did it correctly. I went from 3, I divided out 1, and so I have x squared. And now I can write my result. So I have negative x squared plus, I don't have to write the 1, plus x minus 2. Remember, for the remainder, it's the same way we wrote remainders last class, that it will always, 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 always be plus. So plus, and then 3 divided by, what do I divide by? 1. Yeah, x minus 1, what I was originally dividing by. So this is my result. And then is x minus 1 a factor? No. No, because the remainder is not equal to 0. This isn't going to stick until we do a couple more problems. We'll do our brain break when we're done with the video. The remainder theorem. The remainder theorem says that if a polynomial f of x is divided by a linear term, x plus or minus a, the remainder is f of a. And I'm going to talk about that more. It's not going to make a whole lot of sense until we do some examples. So the next 4 problems are all built off of the same polynomial. So we're going to use this polynomial for everything. So we have to first check it for missing terms. 5, 3, 2. Am I missing terms? Yes, let's fill them in. I'm going to fill them in. You fill them in. Let's make sure we get the same ones. So I'm going to have a plus x to the 4th. Yep. 5, 4, 3, 2, 1, and none. So now I can double check. 5, 4, 3, 2, 1, and none. So I've got all of my places. And so when I start writing this out, I'm going to have 1, 2, 3, 4, 5, 6 numbers that I write out. These problems, It says, what's f of 1? What's f of 4? What's f of 0? What's f of -2? So one way that were taught how to solve these back in algebra, and we've even done this in algebra 2, is that if you want to know f of a number, you can take that number and you plug it into the x value, and that tells you what it is. So again, I could take this number, I could take 1, because that's what, instead of f of x, it's f of a number. So you take that number, I could take 1, and I could plug it in for x everywhere that I see x, and I could solve it. I could work it out. Another way you can do that is that when you do synthetic division, f of whatever that number is the remainder. So whatever we get from the remainder, so like f of -3 is 0. F of 1 is 3. It is the remainder, not any other stuff. It's just the remainder. So that's how we're going to set these up, because the problem says solve it using synthetic division. So I have to set it up using synthetic division. But first I have to identify. These are slightly different because when I was doing the other problems, I was dividing by x plus or minus something. Now it's just saying f of a number. So here, instead of x, I see a 1. So this is saying that x is equal to 1. For this one, what's x equal to? I'm not changing it. That's my point. X is equal to 4. X is equal to 0. X is equal to -2. So what you see is what you get when it's written like this. So now I'm going to set it up to do synthetic division, putting that little number in the box. So I have 1. And then I'm going to set it up with my numbers across are going to be 1, 0, -13, -12, 0, 0. Oh, skipped. And I'm going to set it up. I'm going to put my bar, and then I'm going to drop it like it's hot. That's how I will always start my problem. So now remember, I will multiply, add, multiply, add, multiply, add. Most of these don't get you numbers that are too big that you can't do them in your head. And of course, on a quiz or a test, I would leave the numbers small enough that you didn't necessarily have to have a calculator, but you could use a calculator if you needed. So I start with 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. -13 plus 1 is -12. -12 times 1 is -12. -12 minus 12 is -24. -24 times 1 is -24 or -24. 0 minus 24 is -24. -24 times 1 is -24. What is my remainder? Yeah, so the remainder is -24. That's the only number I care about. I can rewrite the problem. F of 1 is -24. Okay, whether or not I ask you, is it a 0? Is it a root? Is it an x-intercept? Like, those all mean the same thing, and it's all dependent on what that remainder is. So is x is equal to 1? Is it a 0? What do you think? Why no? What's been our answer every time? Because the remainder isn't equal to 0. It's the same answer here. So no, because the remainder is not equal to 0. The remainder has to be equal to 0 for this to be a 0 or to be a root or to be an x-intercept. We're going to set all the problems up identically the same across. The only thing we're changing from B, C, and D is what number goes here. So when I set up for B, I'm going to put a 4 there instead, but it'll still be the same numbers across. Start my problem, I have to drop it like it's hot. Once I drop it, 1 times 4 is positive 4. 0 plus 4 is 4. 4 times 4 is it's positive 16, so plus 16. 16 minus 13 is 3. 3 times 4 is 12, plus 12. So negative 12 plus 12 is 0. Anything times 0 is 0. 0 plus 0 is 0. Anything times 0 is 0. 0 plus 0 is 0.
Wait, maybe where do we get 16 from?
4 times 4 is 16. So we always multiply, add, multiply, add, multiply, add. Remainder.
0.
0. So is x is equal to 4? Is it a root?
Mm-hmm.
Yes, because because the remainder is equal to 0, and I need to rewrite the problem. F of 4, when you're doing f of a number, it's always just equal to the remainder, only the remainder. It equals 0. Let's do another one. We're setting it up exactly the same. The only number that changes is what goes in the little box. 1, 0, negative 13, negative 12, 0, and 0. So I always start by dropping it like it's hot. So I got to drop it like it's hot. 1 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. Negative 13 plus 0 is negative 13. Anything times 0 is 0. Negative 12 plus 0 is negative 12. Negative 12 times 0 is 0. 0 plus 0 is 0. 0 times 0 is 0. 0 plus 0 is 0. So again, we will multiply and then add. Multiply and then add. Multiply and then add. What is my remainder? 0. The remainder is 0. So is 0, 0, is it an x-intercept? Yes, because the remainder is equal to 0. And I can say that f of 0 is equal to 0. All the other numbers don't matter. If I just ask you to divide, you want all the numbers. That's your result. But if I'm just asking you f of a number, only the remainder counts. That's all I care about. The next problem, I'm going to set it up the same, but this time I'm going to put negative 2 in the box. And I would like to challenge you to work this one all by yourself and then look up when you're done. This will be the first problem you do all by yourself, so I challenge you to do it all by yourself.
This is easy.
It's not bad. Remember how you thought you were so bamboozled last class?
I couldn't do it.
Guess what? Some of the oh, you mean day 1.
This test counted as a grade you can drop at the end of the semester.
How did y'all do? Guess what? You can also check your work in the calculator. It's pretty quick to check your work. So what you would type into y equals is you would type in the polynomial the way that it is given to you. So you would type in y equals, and then you would type this stuff in. So you type in x to the fifth minus 13x to the third minus 12x to the second. And you don't have to write the placeholders. Once you type it into your calculator, you can go to the table. And when you go to the table, all you're looking for is this value. So you would go to the table and you scroll up till you find x is equal to 1 and y will be equal to negative 24. And then you can scroll down and you find 4. And at 4, it'll say that y is equal to 0. When you go to 0, it'll say that y is equal to 0. When you go to x is equal to negative 2, it will tell you y is equal to positive 24. So you can use a calculator to check all your answers. And that's what you should definitely do on the quiz or on the test. Check your answer. There's no reason you should get it wrong. Check your answer. Any questions over synthetic division? All right, that's all we're doing today.